Here we are at our example 1 from our 4.2 set of notes. Before we dive really into that, we're going to look at our definition for vertex form. And as you can see, it is y equals a times the quantity x minus h raised to the second power plus k. And that vertex, the reason why we study vertex form is instead of like standard form where you have to do your whole x equals opposite of b over 2 times a, find that x value, and then plug that in to find in y. So again, that would be for standard form. Just want to be very clear there. For vertex form, which is the one that we currently see in our definition, they actually give us that vertex right away. And our vertex comes out to be h comma k in this case. So it's always going to, I always tell my students, it's always going to be the opposite of what's inside your parentheses, and then you take k just as it is. Okay? And so that's why in the definition, you see how it says x minus h? That's why then for our actual coordinate for the vertex, it's just a normal h. And then the k value we just take as it is. And once you see some examples, that'll make a lot more sense too with the numbers. Now, as we look at example 1, we have to graph this following quadratic function. We're still talking about u-shapes here. And it says y equals the quantity x minus 3 squared minus 2. So our vertex in this case, again, we're just going to take the opposite of the value that's inside the parentheses. That acts as your x value. So in this case, since it says negative 3 there, we're going to go with positive 3. And then our k value, we take just as it is. So in this case, notice how there's a negative 2 in front, that negative rather. We're going to then have our y value be negative 2. So again, to find your vertex, it's just the opposite of the value that's inside your parentheses, and then your y value comes out to be just take whatever that is. So we'll go ahead and graph that. 3, negative 2 is located right there. Now, the beautiful thing about actually a lot of this table is it's really similar to standard form. So our axis of symmetry, that's not changing. It's still going to be x equals 3 coming from your x value from your vertex. And again, that's your up and down mirror. So this is your axis of symmetry right here. Now, again, the vertex form, the bonus with finding the vertex was this part was easy. This was they pretty much handed to you. The y-intercept, you actually have to do some of the math, okay? Now, fortunately, the math usually isn't that hard, and not much changes in terms of like the overall process. Like you're still going to, for example, plug 0 in for x, just like any other function, but then you actually have to find out what the y value is. And with standard form, it was nice and easy. You know, it was just the c value at the end. Whereas for vertex form, we actually have to find out what that value comes out to be by plugging 0 in for x. And so when we do that, we end up with y equals 0 minus 3 comes out to be negative 3 squared minus 2. And then negative 3 squared gives us 9 minus 2. So that y value comes out to be 7. So that's what I mean by you have to do a little bit of math to actually find that y value. And so our y-intercept then comes out to be 0, 7. So then that would be located right about right there. Now, again, you're still going to reflect that and mirror that. So since that was 3 units to the left of the mirror, we would go 3 units to the right of the mirror, put a little dot there. And then just say, oh, that reflection point is at 6, 7. And just like before, you're going to plug in another value that you haven't yet chosen. Again, we want to stick close to the vertex, but you can pick, a wide array of different numbers. You can go with like 1, 2, looks like we haven't used 4 or 5. So, whichever value you're thinking that you want to go with. But I would suggest one of those. So let's go ahead and go with, we'll just go with 1. So now, again, I do have to plug in 1 and see what I get as a result. And so when I plug 1 in there, I have y equals 1 minus 3 squared minus 2. 1 minus 3 comes out to be negative 2 squared minus 2. So then y equals negative 2 squared is 4 minus 2. So then that y value comes out to be 2. So when I plugged in 1, I got a y value of 2 there. And so there would be my, that'd be the y-axis. Let's see. 1, comma 2 would be right there. And so when you mirror that, notice how it's 2 units to the left of the mirror. You got to go 2 units to the right of the mirror. And then that reflection point looks like that is at 1, 2, 3, 4, 5, 2. And so that would be your reflection point. If you went ahead and you tried like the value 4, you would end up with negative 1. Okay, so if you plugged, that's the domain. If you plugged in 4 instead, you should get a value that's negative 1. And then your reflection point would just be 2, negative 1. And these guys can flip-flop too, again, just because you picked them. So, but those are some of your other coordinates too, to just help you out with the general shape of this graph. All right. And there you can kind of start to see the U forming a little bit more clearly. So if we just connect these dots, then we end up with a general shape that does something like that. Okay. Now for our domain, again, this is not really changing. So this is still from negative infinity to positive infinity. It's going forever that way and that way. So that's why that is our domain. For our range, again, we read that for our y values from bottom to top. The bottom value here looks like negative 2. And then it goes on and upward forever. So comma infinity. Can't ever obtain infinity, so you do have a parenthesis around the infinity. Negative 2, since that is your vertex, you can be that, so you do have that bracket there. Again, though, that is example 1 from our 4.2 set of notes.